In California, for example, a lot of the electrification work that's going on there is driven by air pollution. And of course, you might be hearing from the gas utilities that renewable natural gas is going to save us, and it's going to be the thing that just makes us able to stay on the gas system, but that's just not true. There's just not enough of it, for one thing. And it's also still burning. As soon as you burn anything, there are really nasty byproducts that are created from that are part of the air pollution problem in the United States. So that renewable natural gas is not really a solution. The solution is, and this is the good news, and the thing that is the future is that there is so much energy available from the wind and the sun. And you can see from this chart here, the cost that it costs to get wind and sun energy has gone from being really expensive to being now the cheapest source of new energy, cheaper than gas, cheaper than coal, cheaper than nuclear even. So this has happened over the last 20 years. And the projections are that these costs are going to continue to go down. And again, this is because it's the same thing that's happening with heat pumps, that the more of these things we make, because they're widgets, right? They're solar panels. The more solar panels you make, the cheaper it becomes to make them. Same is true with wind turbines. So these prices are going to go down. And this is why this is inevitable that we will be switching to these renewable sources because they're so much cheaper. But right now there's a lot of headwinds associated with that. And this is why all of us can play a big part in this by putting solar on our roof, which we'll talk about, or embracing other forms of renewable energy like community solar, and being part of this electrification movement to move away from burning fossil fuels in our own lives. Okay, so let's think about this from a household perspective. If as a kind of regular person, the data shows that about 60% of the emissions that we're responsible for as regular people comes from the energy that we burn in our homes. So yes, there's emissions related to the food we eat and the products we buy, et cetera, but 60% of our household emissions are from burning fossil fuels. And the big ones are our electricity consumption, which we'll talk more about. Like one gas car is 4 to 8 tons of carbon emissions. A gas furnace is about the same. And of course, these numbers will vary depending on how big your house is, how much you drive, et cetera. These are average numbers for Oregon. A gas water heater. These are the 4 largest sources of carbon emissions in most of our homes. And if you have an electric home now with an electric water heater, it would be slightly less, but still these 4 things are the things that are the largest consumers of electricity, of energy in our homes, and therefore the largest sources of carbon emissions. There is a huge opportunity when we combine renewable energy and electrification to eliminate those emissions. We can get renewable energy for electricity. The state is on the way towards doing this. We have laws already in place that are mandating that we get to this, but you can do this right now in your own home by getting solar on your roof or subscribing to a community solar program. Then you can use that clean energy for your transportation. So now that's 0 for driving around, and 0 for heating and cooling your home, 0 carbon emissions for heating and your water. So when you look at this in total for an average home in Oregon, and again, this is going to vary depending on the size of your home, but an average home with 2 cars is 27 tons of carbon emissions every year. It's kind of mind-blowing. You don't see this, but this is what is happening through burning fossil fuels. And if you electrify that home today with the grid the way it is, you would cut those emissions in half just because of this incredible efficiency of these devices we're going to be talking about in just a minute. And you'll cut your energy bills in half as well, which is one of the reasons why this is exciting, because a lot of people may be motivated to do this from a environment standpoint, but there's lots of kind of like personal benefit reasons to do this as well, and we'll talk about those as we go. But cut your carbon emissions in half, and then of course, as we go towards renewable energy, with an all-electric home, it's possible to get to 0 emissions. It will never be possible to get to 0 emissions if we're burning fossil fuels in our homes. So that is why this is such a powerful thing for us to know about and to think about doing. That's why you hear people talking about this idea of electrifying everything, which is kind of conjuring up this future where we get power from the wind and the sun for our electricity, and then use that electricity for transportation, and use that electricity for heating and cooling our homes. And there's these incredible side benefits. You know, I came into this conversation really focused on carbon emissions, but I realized from doing this that there's unbelievable energy cost savings that roll up to hundreds of billions of dollars when you look at the United States in general, as we transition away from fossil fuels. It delivers clean air, because think about it for a minute, where does air pollution come from? It comes from our cars that burn fossil fuels. It comes from power plants that burn coal, etc. So it comes from burning stuff. So as long as we get, sooner we get away from burning things, the cleaner our air will be. There's amazing amounts of water that's used for processing fossil fuels that could be available for much better uses like drinking or agriculture, for example. All this leads to healthier people, which means that we're spending less money on healthcare and less money on energy, which is better for the economy. So there's lots of exciting reasons to do this beyond just the environmental impacts. Okay, so what does that really mean to do? Well, the thing that I hope you will walk away from today, if these things are new to you, is a little bit of an understanding of the kind of key technologies that we all need to be familiar with. And when the time comes in our homes, when our water heaters break, you can replace it with something that's way better if you know about what's out there. So that's the point of tonight. So heat pump water heaters, we'll talk more about it. Heat pumps for space heating is another key technology. Induction for cooking is so much better than cooking with gas, even though gas has this reputation as being the best cooking technology. It gets blown away when you look at if you ever experience induction. We'll talk a little bit about that. We won't be talking about this so much today, but even electric fireplaces are out there. It's a thing. You wouldn't even know the difference between an electric fireplace and a gas fireplace if you saw one, but they don't burn fossil fuels. Heat pump dryers are incredibly energy efficient. And then, of course, electric vehicles, which we will talk a little bit about. But this is kind of the suite of technologies that enables us to take any home, any apartment building, any commercial building, and get off of fossil fuels for heating and cooling and cooking, etc. Okay, so a lot of this, you've already heard me say this word heat pump many times, and a lot of the technologies we're talking about relies on heat pumps. They're really incredible devices. I'm not even going to try to explain how they work because they're a little bit magical in some ways. But I think the simplest way to understand them is that they've been in our lives forever. A refrigerator is a heat pump. The air conditioners in our cars and our homes are heat pumps. So this technology has been around literally for 100 years. It's just become more and more and more perfected over time. The way a refrigerator works is that it's moving heat from inside that box into your kitchen. You don't really notice this, but your kitchen is getting slightly warmer because your refrigerator is getting colder. And so you might, if you put your hand behind there, you can feel the heat coming out of it, or sometimes there's heat being evacuated from underneath. It can be freezing inside, literally freezing inside your refrigerator when it's 100 degrees in your kitchen. So these things are incredibly efficient in moving heat from one place to another, and use little tiny motors and pumps, very little energy to move heat from one place to another. So that is the magic that makes a lot of these things work. A heat pump water heater is kind of, in some ways, the easiest to understand because it's like a refrigerator in reverse. So instead of kind of making your room warmer by cooling what's inside of the refrigerator, a heat pump water heater is going to make the space that it's in slightly cooler in order to absorb that heat and concentrate it into the water that you're using. So they look just like regular water heaters, but they're absorbing heat from the air, exporting cool air, and then using this refrigerant that circles around the water tank to heat the water. And you can get water up to 140 degrees or even hotter with this technology. Plenty hot for what we need in our homes. All the major manufacturers who make water heaters today are making heat pump water heaters. They've been around for over 20 years now. They have incredible warranties. This is not some kind of fringe technology that's brand new. A warranty on a gas water heater is 6 years, by the way. A warranty on a heat pump water heater is 10 years. It gives you an idea of how much confidence the manufacturers have in this technology. This is here to stay. The federal government is essentially trying to get this to be the new standard for water heaters, period. And one of the reasons for that is what you see over here, cost of operations. A heat pump water heater on average is going to cost about a little over $100 a year to operate, compared to The most efficient technology out there is a gas water heater, a gas tankless at 350. So this is, that's 3 times more money every year you're spending for what was the most efficient technology until heat pumps came along. So heat pumps just blow everything away in terms of cost of operations. And because of that energy efficiency, it also means that the carbon emissions they produce is teeny compared to these other technologies. And if you do what you're going to hear about in just a minute, this would be zero, literally zero over here, because if you're powering this with renewable energy, this goes to zero. There's no way for this to be zero, because of their burning fossil fuels. So really amazing technology. There's unbelievable incentives. We'll talk more about this later, but a heat pump water heater, this is information that's available on our website, but you can purchase a heat pump water heater for $700. They retail for more like $1,600. That's an incredible savings. That essentially makes these things about the same cost as installing a standard low efficiency product. That's why the incentives are so important. So more about that to come, but that's one of the key technologies. The other one is heat pumps for space heating. These things have also been around for a long time. Some whole countries use this for space heating, like Finland and Norway. Really cold places have been using heat pumps for a long time. So there's no reason to think that these things aren't going to be powerful enough to heat our homes here in the Northwest. The coldest places in America, like Alaska, Maine, and Vermont, are embracing these devices. They are incredible because, one, because of their energy efficiency we'll talk about, but they also lead to more comfortable homes because they operate relatively consistently. If you think about a gas furnace, for example, when you turn it on, it's creating this unbelievable amounts of heat, way too much heat to really use, like thousands of degrees. So literally. So the way that you make it work is you turn it on and off all the time so that your house doesn't get too hot, literally. And with a heat pump, it's producing temperatures that are more like 120 degrees or maybe even less. It depends on the situation. So they're operating almost continually. And therefore, what that means is that you've got more air through your filter, which means cleaner air. You have that air that's moving into every corner of your room. So you're likely to get really consistent temperatures throughout your whole house, no cold spots, etc., which leads to this noticeably more comfortable homes. So they're good from that standpoint. And then we'll see from an energy efficiency standpoint in a minute. They come in basically 2 forms. You see them in what's called a ducted or central system. So if you've got a gas furnace now, for example, you would replace that gas furnace with an air handler, which is blowing the air through your ducts, the same ducts you already have. You have this external unit that's harvesting the energy from the air and then converting that to either heating or cooling, because it can do both, which is one of the other magical things. It essentially replaces an air conditioner for cooling. If you don't have ducts, if you've got electric baseboard heating, then one of these ductless systems would be what you want. It has a similar unit outside, but instead of blowing air through ducts, there's these mini splits, they're called, or high wall units. They're usually mounted in every room to blow warm or cool air into the room for conditioning. And in some homes, you might combine these. Yes?
I have a heat pump. I have a heat pump in my house right now. And when it gets down to about 34, 32 degrees, my electric strips come on.
Yeah.
So are the new heat pumps made differently so you don't have to use electric strips or what?
That's a great question. And so if you didn't hear that question, basically the question was about what happens when it gets cold, because some of the older generation heat pumps will work really well till about 30 or 35 degrees, and then they'll switch to some sort of backup heat, either a gas furnace or electric strip heating, electric resistance heating. So a lot of us might have these older heat pumps that have this backup situation, which is electric resistance. And that actually typically works fine. You might not even notice it, but one of the downsides of that is it's more expensive when you switch into resistance mode, because now you're not as efficient. So your bills are going to go up. And it's not a great thing from an environmental standpoint as well, because you're just using more energy. So the newer versions of heat pumps are capable of providing heat down to 5 degrees or lower. I mean, some of them will go down to -13 with all their rated output. So there is this new generation of heat pumps that are available that make it possible not to need that kind of backup resistance heat, particularly here where, you know, we have a climate where it's very rarely going to get below 20 degrees here. And even if it does, these things are going to keep your house warm. So it is important to get if you're thinking about this, you know, make sure you have a really good conversation with your contractor about what that set point temperature is, where it would go into backup heating. Typically, you're going to spend a little bit more for a unit that is capable of going to lower temperatures, but you're going to get that payback by lower energy bills. Another question here.
Where's the cutoff, like you said, of the lower unit to the during unit or efficient unit? Where's, how old is old?
Well,
When you want to switch?
you know, I don't know that I'm not sure there would be, if your heat pump is working today and you're comfortable with it and your house is comfortable and you're comfortable with the bills you're paying, I'm not sure I would rip it out and put a new one in. But for example, one of the things we're going to talk about later is incentives, and the Inflation Reduction Act has incentives for heat pumps. There's a efficiency requirement for the heat pumps that qualify for those incentives. And those are the ones that are going to get you down to these lower temperatures. So they used to be called cold climate heat pumps, but as I talk to the manufacturers, more and more, it's like everyone's just going that direction. These heat pumps are getting more and more efficient all the time, which means that they're capable of delivering heat at lower temperatures. Okay, so just generally speaking, just like water heaters, all the companies that are making gas furnaces also make heat pumps. So these are all brands that we grew up with: Carrier, Trane, you know, Lennox, etc. And then some new brands you might not have heard about because the Japanese really perfected this technology. So Mitsubishi, Daikin, Toshiba, other brands like that have been really perfecting this technology, and they've teamed up in a lot of cases with American suppliers. So like Daikin, for example, works with Trane. And so, you know, it's all kind of a mishmash of technologies, a lot of it coming from Japan. But the basic idea is that all these companies, very reputable companies that make these devices, and you can see again, just like water heating, it's the most efficient solution that's out there. And depending on what you've got right now, particularly if you have electric baseboard heating, or in some cases, you know, some people still have oil furnaces, you can save thousands of dollars a year in heating costs by going to a heat pump. The savings from transitioning from an efficient gas furnace are going to be less, but they're still here in this area because of our electricity and gas prices. There's still savings to transition to heat pumps, even if you've got a gas furnace. And then, of course, from a carbon emission standpoint, there's nothing that rivals a heat pump in terms of its carbon emissions footprint. And the other thing that I think is really exciting that you see happening, I pay very close attention to this. You know, 5 years ago or 6 or 7 years ago, gas furnaces were massively outselling heat pumps because that's just what people knew about. That's what people were comfortable with. But as more and more people understand the advantages of heat pumps, this has completely changed. So now the vast majority of systems they're being sold are heat pumps because people just get it. They're better. And this is, I think this is going to be in 2025. I think these numbers are going to go up and these numbers are going to continue to go down for this reason. So I guess what I like about this, showing this, is if you're thinking about doing this, it's not like you're alone or that you're on the edge of, you know, the cutting edge of technology. This is a big movement that's happening across the country. Question over here.
I had some questions of the company we work with. I was wondering if there's any resources out there for.
Yeah.
I really trouble finding.
I love that question. The question was essentially, I would paraphrase, the contractor that she worked with, and this is not uncommon, you know, might not be very familiar with heat pumps, or they might prefer to sell you a gas furnace because that's what they're most comfortable with. This is not uncommon. So I think one of the things that's hard as consumers, when we call a HVAC installer and that person is sitting across the table from us, they're kind of the expert, right? Not us. So if that person says, well, if it was my home, I'd put in a gas furnace, it's hard to kind of argue with that. most likely a guy, because they've been doing this their whole career. But the truth is that if you find the right contractor, you will find that there are people who've installed hundreds or thousands of heat pumps and have had really good success with this, know how to answer your questions, to your point about, what's right for your home. So at Electrify Now, one of the things that we realized early was that, because we had this experience with our own home, where someone was trying to talk us out of these things. And we have developed a list of contractors that we feel really comfortable with, that know the technologies, give you good service. And in some cases, we'll even pass on a little discount because we send them a lot of business. We don't want to make money off that. That's not who we are. We're a volunteer organization. We'd like to pass that savings on to you. So in many cases, you'll get a discount from working with these folks. All that information is on our website. I'll show you later, but it is really important. It's a good question to make sure you're working with the right person. And a general rule of thumb is if you hire a contractor or have someone come in and give you a bid and they tell you they think you should get a gas furnace, I would not work with that contractor, because you should at least find a second or third opinion, because most likely there's a heat pump solution for you in your home. Okay, so I don't want to go too long here, but the induction cooking, anyone here have an induction stove?
I have an induction cooktop.
Induction cooktop.
It's just a little burner, it cost me $57.
Yeah.
And, I'm a climate activist like you are. By the way, I will testify that everything he said is true.
Thank you. Thank you. I don't know if you could hear that out there. He just said everything I said is true. So thank you.
I bought it because I wanted to advocate for induction cooking, because everybody I knew that had an induction stove loved them, but I wouldn't want to recommend a $3,000 range to somebody.
Yeah.
It's a pretty big investment. So I bought one of these off Amazon, and I love it. I use
Yeah.
it for about 80% of my cooking.
They're great.
My other stove, which happens to be electric, just sits idle most of
Yeah.
the time. And that's a good way for somebody who doesn't want to buy a $3,000 induction stove to get all the benefits. Of
Yeah, that's an excellent point. Excellent point. So you'll save me from making that exact point later. So thank you. Yeah, but I think it's fair to say anybody who's cooked with induction would never go back to gas. I mean, we were big gas stove users. These things are just better. There's a lot of environmental reasons to use them, but just from using them, it's one of the things you use most in your life if you like to cook. And you will massively enjoy these things because they have much more precise temperature control. They're faster to heat up and cool down. They're easier to clean and much, much safer. So let's just need to advance this way. You've probably been hearing about the dangers of gas stoves. I don't want to go too long on this, but they emit these, when you burn gas, it's emitting particles in your home that your exhaust, even a really good exhaust system, is not going to evacuate. That leads to higher risk of asthma, cancer, dementia, all sorts of really nasty things. The American Medical Association said that your kids are 42% more likely to have develop asthma if they live in a home where a gas stove is being used to cook. And Stanford has said that even a single gas burner in a stove is basically like having secondhand tobacco smoke in your home regarding your risk of developing cancer from benzene and other chemicals that come from that. So it's no joke. These things are not safe. Induction has none of those problems, but it also doesn't leak methane into your homes, which is also a problem more and more that we find with gas appliances. There's no risk of fire, essentially. The surface stays cool because the only thing that gets hot is the pan. The molecules in the pan are excited by this induction coil. And so you get incredible energy efficiency from that, but also real safety benefits. And they also heat your water or anything faster. This is a study that was done by an outfit in California. Literally twice as fast to boil water with induction than even a really big gas burner or in the electric resistance. So lots of reasons to be excited about it. This is the product that you were mentioning, these little tabletop units that you can plug in. They're very low cost if you just want to try it. These ranges typically are more expensive. They're entry points at about $1,000 now for a slide-in range, compared to maybe $600 for a electric or $700 for an electric. And then of course you can get them as these built-in cooktops if your kitchen is built that way. So lots of reasons to use them. finally, just on electric vehicles, most of us are kind of understand electric cars. You see them more and more. If you've ever driven one, you'll know they're just like blow everything away in terms of acceleration, cornering, blah, 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 you name it, in terms of performance. But one of the things that most people don't appreciate about EVs, because we all have this impression that they're more expensive, which is true to some degree because the sticker prices are higher. But check this out. This is a comparison between two versions of the same car, the Hyundai Kona, which is a really nice little gas car. Gets about 32 miles per gallon. So with $10 worth of gasoline, you can go about 93 miles. The electric version of the exact same car, literally, you could hardly tell the difference, except this one's got an electric motor in it. For $10 worth of electricity, you can go 262 miles. So this is why the industry recognizes that this is inevitable, but it's also why, even though that sticker price is higher, and those things are getting closer and closer to the same all the time, but they're still higher than, so this one is about $8,000. Sorry, this one is about $8,000 more than that one right now. It used to be 12. But when you factor in the rebates that are available and also this cost of ownership thing, within 5 years, you're saving thousands of dollars every year. So no reason to be shy because of the sticker prices. And then, of course, from a carbon emission standpoint, these electric vehicles blow the gas ones away. And this is a really good apples to apples comparison of these two vehicles. You're less than half the emissions, and goes to zero if you use renewable energy. And again, the same thing is happening here as with heat pumps. It was roughly 10% of auto sales last year, up from, like 1 or 2 just a few years ago. And here in Oregon, it's 16% of sales as people, that's why you're seeing more and more of them on the road. People are getting the word. Okay, so incentives. This is a little bit of a complex topic, and we won't be able to go into all of the things that are available out there. This is just sort of a summary of what's available on these key technologies that we talked about from various sources, either from the state or from the federal government. So I'll show you some sources where you can get more information on which ones of these things might be interesting to you. But the IRA provides these amazing federal tax rebates. So if you have a tax burden now, you can get incredible tax rebates, tax credits. Sorry, I was struggling for the words, not rebates. Tax credits for some of these devices, like it's $2,000 for a heat pump water heater, $2,000 for a heat pump. But the state, like through the Energy Trust of Oregon, has huge incentives for water heaters and heat pumps also. You combine that, you're talking about thousands and thousands of dollars that's available to you. A lot of these have different income requirements, et cetera, and some of them come from utilities and have different utility requirements. So you really need to dive into your personal situation to know what number is out there for you. But these are big numbers, including for EVs, energy audits, weatherization, et cetera. Question?
So these companies that you've done some research into locally,
Yes.
installers, so on and so forth, they're gonna know about all these things.
I'm glad you asked that. A good heat pump contractor, for example, is going to know the incentives that are available to you. But I think it's still smart to do a little research yourself. And so I'm going to give you some links, places where you can go to do that, just so you know that they're telling you the truth. But usually the good ones are very up to speed on this. Yes.
Just got a quote for $15,000 for a heat pump, just the heat pump,
Mm-hmm.
and not a dime a mention about.
Really
any
interesting.
kind of incentives.
Interesting. Yeah. That's not a
And
good
a
sign.
big local company. Big.
Yeah. That's not a good sign, because I feel like if these guys aren't on top of it, it's like, wow, how would you not be on top of this? This is like a essential thing that's out there to reduce the cost. So, yeah, again, if you go to our website, I'll show you in just a minute. We have really good list of contractors and I recommend that people get bids from at least 3 people, because even the good ones, the ones that we recommend, one or the other of them might have a better promotion going on, or might have equipment that better fit your homes a little bit better. So it's always good to get several opinions. But there's really good incentives available out there. Here's some sources. First of all, this is our website. If you go to our Take Action page, it looks like this, with information about how to do all these things that we just talked about. depending on what you're interested in. If you're interested in an electric vehicle, go there, etc. And then there is this incentives page, which has really good information about the incentives that are available from the federal government and other places. Energy Trust of Oregon is another really good site where, it'll ask you some information about your home, depending on what, again, you're interested in, and it'll tell you the incentives that are available to you. I highly recommend checking that out. And then there's a new one that's just kind of coming on now called, it's called Incentive Programs in Oregon. Sorry, it's being covered there. Incentives.oregon.gov. It's a little bit new, so they're still working some of the bugs out. But their idea is to try to be able to amalgamate all the incentives that are available to you in one place rather than have to hunt around from place to place. So I highly recommend checking that out. Incentives.oregon.gov and energytrust.org and electrifynow.net. Those are the three that I would recommend you check out. And yeah, thanks. So we've gone probably a little bit over here. So I'm happy to answer questions. Probably I should do that afterwards. I've managed to get a few along the way, but I'll be over there. Please come see me if you've got other questions. I'd be happy to answer them for you.
Hello, everybody. My name is Nicole, and I'm a program manager at the nonprofit Solar Oregon. I'm definitely newer to this industry than Brian, so it's great to have him go first and share more about energy efficiency and all those different improvements you can make to your home. I'm going to be focusing more on the solar and solar plus storage side. And yeah, before I get started, I would just love to know, does anyone here have solar already? Awesome. And do you guys have storage as well paired with that? And are you interested in learning more? Okay, awesome. Does anyone have community solar? Great. Thanks for telling me a little bit more about you all. I'm going to just kind of go through this presentation, and then I'll leave some time for Q&A at the end because I'm sure there'll be questions about solar. So we'll just jump right in. We'll talk a little bit about the basics of solar, how a solar contractor or you might assess if your home is a good candidate for solar. We'll talk about the incentives available for solar. I know Brian shared about those, and we'll just go a little bit more into detail, and then also talk about how you can find a solar contractor. So a little bit about Solar Oregon. We are a nonprofit, and we really focus on education. So educating folks about solar and storage. We do that through events like this, workshops. We also do tours in person. So we had a tour yesterday, which is great. So if getting in person and checking out local projects is something that you'd want to do, you can follow us and join more of our events. And then we are a member-based organization, and so our members do get discounts on our Go Zero tour, which is our annual homes tour of homes that have solar and our path to zero energy. Does anyone know what a zero energy home is? We use that terminology. Yes.
Is it like the living building challenge?
That's like a good yeah, that's a good direction. Yeah, you're bringing up a lot of terminology. So like for zero energy buildings, they usually have a lot of these energy efficiency measures that Brian talked about, like heat pump water heaters, so that they're reducing their footprint. And they usually have solar and sometimes storage so that they can use renewable energy. And then passive house is another term that you brought up. And so passive house is a way of designing houses to be more efficient in their design. We have an annual tour for that. So if that's something you're interested in, you can join us in the fall there. We have some in-person sites, and so it's fun to go see what your neighbors are doing and what energy efficiency and solar projects they have installed in their home. Join our next event. We're doing a comparing solar quotes workshop. And then Brian brought up Energy Trust of Oregon, and so they are an independent nonprofit, and they have incentives for things like heat pump water heaters, as well as for solar. And so we'll be talking about those incentives for solar. All right, has anyone seen a diagram kind of like this that shows, yeah, so it's pretty basic, just kind of showing how solar works. So For a residential grid tied system, it might look something like this. And grid tied means that you're connected to the utility. And so off grid would be like if you're a cabin out in the woods. But in this example, you can see like you have PV panels, sometimes called photovoltaic panels. And so those are your solar panels that would be collecting the sunlight and turning that into a special voltage of electricity. And then that voltage of electricity is actually direct current or DC. So it would need to get converted to alternating current, which is what's used by your homes and by the appliances in your homes. And so usually connected to the panels, there'll be either an inverter or a microinverter. Both of these work. It just depends how your system is laid out. Solar is highly customizable. So when you meet with a contractor, you'll share what your energy consumption is, what the plans and goals are for your home, and they can customize a system for that. And then that energy, once it gets converted, will go to your electrical panel where then it can be used by the appliances and outlets in your home. When you get solar and you have a grid tied system, you'll actually get a special meter called a bidirectional meter. And so that will measure the flow of electricity out from your house back onto the grid. And also if you need to pull from the grid, it'll measure what you pull from the grid as well. And then there's a special agreement called net metering. And so this is the agreement where you get credit for the energy that you send back out to the grid. And so has anyone heard of net metering before? Yeah, okay. So here in Oregon, you can do net metering. And so for PGE, it's a 1-to-1 right now. And so when you sign up and you get your solar and you're interconnected, you will be part of this net metering program where you can gain credits. And this credit system, it starts during the sunnier months. So it's actually going to start in April so that you can build up credits from the electricity that you produce with your system. And it's going to build a bank of those credits that you can pull from when you need to draw from the grid. So you can see here a typical summer month. So you might be producing more. It's sunny, it's not cloudy. We have less rain, so you're producing more. And you might be producing more than you consume depending on your system, because like I said, it's really customizable. And so you'll have a net metering credit earned, and that would go into your year-to-day bank. And then you could pull on that in a winter month when your system might be producing less. So this is just an example energy bill and some key things here. You can see that it's going to read your different service periods, how much energy you consumed, and also what you produced. And so in this example, this person actually, or household actually created more energy than they consumed. So they were a net exporter and sent that extra energy back out onto the grid. And so they got credit for that in their year-to-day bank that they can pull from later in the year. Like I said, the net metering year starts in April. And so it goes all the way through March 31st. And at the end of that, you don't get like a magical check payout for that. What happens is that anything that you don't use will be donated to the grid to low-income subscribers. So it is still doing good, and you're sending that energy out to your community. But it's really important to match your consumption to your system design so you're not ending up with a ton of extra export. And then something you might notice about this bill, it isn't zero. And that is because you're a grid tied system. So when you're interconnected, there are certain fees you pay to be connected to the grid for grid maintenance, things like that. And so even though this example, they net exported, they still pay a small fee to be connected to the grid, but it's a lot less than a typical energy bill. Like I said, you really want to be matching your system size to what you consume. And so your solar contractor will look at your previous energy bills and help try to match that consumption. If you're looking to make any upgrades, like adding an EV charger to your home, that's a good conversation to have with your contractor so you can plan for those loads. And then also you'll be considering, what available space you have, budget, aesthetics. If you are part of an HOA, sometimes there are restrictions on where you can install the solar. And so that's a good thing to check. And then solar in Oregon, average size is about 8 kilowatts. But it just depends on what you need for your system. All right, so we're just going to jump into some ways you can assess your home and decide if it's right for solar. First, you need access from the sun. Pretty obvious, right? So you need to be getting some sunlight on those panels so that you can create electricity. And so here in Oregon and most places, the south-facing roof is going to be the best. Solar is also installed on east and west facing, but you normally will not see solar installed on north-facing roofs. So if the only roof that you have that's not covered by shady trees is north facing, maybe you can look at other options like putting the solar on a different outbuilding or doing ground mounted solar or even participating in community solar. So I talked about shade. Trees are great. They have a lot of good positive benefits for your home. So don't be sad and lament if you have trees. They're still good. It's just if you're fully shaded out, it's going to be harder to install solar on your roof. Roof complexity also plays a role in the system design. So for a roof that is more simple and maybe has less steep pitches, it's going to be easier to have a simple system installed. Roof condition and age plays a huge factor in installing solar. Does anyone know on average how long solar panels last? Any guesses? Yeah, so 20 to 25 years. So if you have a roof that doesn't match that lifespan, let's say your roof needs to be replaced in 5 years, if you were to install solar, you'd have to uninstall it, put on a new roof and reinstall, and that creates an additional cost. So if you are re-roofing, that's a really good time to go solar because you can match out that lifespan of your roof with the lifespan of the solar panels. And then as far as different types of roofs, solar can be installed on many different types of roofs. Contractors usually have experience with multiple types, and most of them are suitable for solar. There are certain engineering requirements required to install solar on your roof. So a lot of new houses will have trusses and have more supports to support solar, but that doesn't mean if you don't have trusses, you can't get solar. It's just something your contractor will be looking at to just make sure it meets those requirements. And if it doesn't, sometimes that just requires some extra supports being in, some additional engineering. So just keep that in mind when you're thinking cost. If your roof is not an ideal candidate for solar, or maybe if you rent, you can get community solar. So that is an option where you would subscribe to a system that's installed elsewhere, and it can help save you money on your energy bill still. In Oregon, we have the Oregon Community Solar Program, and there is a standard program and also an income qualified program. So Community Energy Project helps folks with the income qualified program. And so this is just some information about them. And I have their flyers at the back. So if you are interested in learning more about community solar, we can connect you with them as well. All right, and then now we're just going to jump right into storage. So is anyone familiar with the topic of energy resilience? It's been a word that's being more and more used in Oregon. Yeah, so exactly. So energy resilience is that ability to access power during emergencies, when there's an outage, when the grid might be down. And so a lot of people are considering that when they're thinking about adding their solar, they're doing solar plus storage, because solar can make storage more effective. You can recharge that battery. So for picking a battery, there's many different brands and chemistries. Right now, lithium iron phosphate is pretty popular. And the average battery size right now is about 13.5 kilowatt hours. Different installers might specialize in different batteries. So Brian brought up getting at least 3 quotes if you can from contractors. This is the same for solar and storage. It's great if you can get 3 quotes. Because different installers might specialize in different panel modules or different batteries or inverters or microinverters. And so that can give you some more options, and also make sure that you're getting the best system for your needs. And then, yes.
What's the difference between an inverter and a microinverter?
Yeah, so the inverter are like the more traditional old school string inverters. So it's one inverter that's connected to a whole array. And so what can happen with that if you don't have optimizers is if part of your array is shaded, you can lose production on those panels. With microinverters, it's a smaller inverter that's attached to 1 to 3 panels, and it actually will be on the back of the panels. And so that can help with shading if you have like partial shading on your roof. Yes. With thinking of energy resilience, some folks are interested in backing up their home and their electrical panels, and there are a couple ways to do this. There's partial backups and whole home backups. And with partial backup, you're selecting specific circuits in your home to back up, and you would need less batteries to do that. To back up an entire home, especially if your consumption is high, you would need a lot of batteries to do that so that you could charge all of those and then be able to pull from them and have that last longer to back up a whole home. So a lot more practically, people are doing partial backups. And when you're considering what circuits to back up in your home, this is another conversation that you'll have, with your household and your contractor, thinking about what needs power and for how long. Common things to back up are refrigerators, a common room with an outlet to charge laptops, phones, etc. So partial backup can help with that. And you can do that with 1 to 2 batteries instead of a whole battery bank. When to install storage. So thinking about planning, if storage is something you're interested in, that's great to tell your installer when you're installing solar or looking to install solar, because then they can incorporate that into the design and how your system is going to function. If you do it later, sometimes there'll need to be new conduit runs, sometimes inverters need to be swapped out, so it can increase your cost. So if you're looking to go solar and thinking about storage, it's good to have that conversation and think of that planning. Storage can be added to existing systems, and it's just a matter of the contractor assessing your site and also your needs and seeing where that can be incorporated. Batteries do need space, not usually this much space. This is a pretty big storage system, but they do have to meet National Electrical Code. So you can't just shove them in a small cabinet somewhere. So they need to be accessible. And so that's something to think about when you're thinking about storage. All right, incentives. So there is the solar investment tax credit. So who's heard of this ITC solar investment tax credit? Okay, great. So this is a 30% of your total cost of your system, and it covers both solar and storage. And it's a dollar for dollar tax credit. It is good to, I'm not a tax professional, let me disclaimer that. It's good to ask your tax professional how to claim it. It's pretty simple, but there are some myths and misconceptions. So something that we've seen online is that you can claim a re-roofing under this tax credit, and it's not covered for solar and storage. If you were getting something like solar roof tiles, which is solar and roof product combined, that is covered under the ITC solar tax credit. But if you're just looking to repair your roof, that's not covered. So it's great if you can, let your tax professional know this is something I'm interested in doing to make sure that you get your full tax credit. And it can be applied over multiple years. So if you don't have enough tax liability in the first year, you can apply it in the next year. And so right now that is out until 2035. But with policy changes, things like that can change. But as of right now, that is the date that it is set to expire. All right, and then we talked a little bit about Energy Trust and like their incentives for heat pump water heaters. They also have a standard incentive for solar as well as storage. So if you're a PGE customer, it's $950 flat for solar. And for Pacific Power, it's $1,100. And they also have a storage incentive too. So that being $475 dollars per kilowatt hour up to a maximum. So the maximum right now is set at 5,700 for energy storage. To get these incentives, you would actually work with an Energy Trust trade ally. And what the Trade Ally Network is a group of pre-vetted contractors and that are vigorously vetted. They also tend to be more local. They're also aware of these tax credits and have approval to apply for them. So when looking for a contractor, if you are a PG or Pacific Power customer, it does help to work with a trade ally so you can get these incentives. Energy Trust also has an income qualified incentive for solar and storage. And so that varies depending if you're PGE or Pacific Power. And again, you would need to work with an Energy Trust trade ally contractor to get these. EnergyTrust.org has their information about their incentives, and also they have a income threshold for this income qualified one. So it's always good to check and see if you qualify, because you might. So that is a good place to check on that. And then we talked about reasons why the cost for solar might vary. And I know they're behind me, but if I just go here, does anyone remember why costs might vary for solar? The condition of the roof? What? How many panels? Yeah, exactly. How big is your system? Structural upgrades, if you're adding battery storage, like what type of inverters are used? Are you adding to an existing system? And then the access to the incentives too can also impact the cost. Like we mentioned, solar and solar plus storage are highly customizable. So there isn't just a one size fits all. So a lot of these systems look different and they're tailored specifically to that site. And then same with storage, costs can vary as well. But it's great to see that there are incentives right now for storage. So if that's something you're interested in, it's good to see if that makes sense for you. And this is, oh, go ahead.
Just got to say, do you have a plus or minus average number you can cover?
Yes, I do. Thank you. You placed that question so perfectly. So yes, this is just kind of an average example budget that we've got here, assuming an 8 kilowatt solar system. And in this example, they also got storage. So it's assuming a 13.5 kilowatt hour battery. And so that they got both. And it shows a couple different customer types. So if you're Pacific Power or PGE, and also if you're income qualified. And then you can see with the Energy Trust incentives, you can decrease your out-of-pocket costs from about $6,000 to $18,000, depending on what you can qualify for those incentives. And then when you go to apply for your taxes, you can also claim that federal tax credit. And so you can see that helps quite a bit. So always, if you're thinking about solar and storage, check out what the current incentives are. Like Brian said, do your own research so you're aware of what might be offered. Checking at the utility and also with Energy Trust. And then when you work with a trade ally contractor, they're aware of a lot of these incentives and how to claim them. Yes, I think I saw this hand and then we'll go to the back.
Average, as far as getting your money back, if you go solar and stuff, is there kind of an average, like 6-7 years?
Yeah, good question. So the question was, what's the average like payback period, right? If you go solar, and I'd love to tell you there's like an easy, like this many years. But because solar is so customizable, it's going to depend. Like, did you size your system to completely offset your load so you're not paying that energy bill? Did you add storage? Were you able to access incentives? Those things are going to impact that payback period. Some people are saying it's ranging from like 8 to 15 years, depending on your system type. But yeah, a good way to kind of see what that might look like is to get some quotes from contractors. They'll have like an estimated annual production on there. And then you can see with actual numbers for your site, what that payback period might look like. Good question. And
say $130 a month on an average on your PG bill for 20 years. Right.
yeah, and it would depend, like, yeah, on your system. Do you consume a lot? Do you consume less? Did you plan for an EV charger that you installed, or did you install it later? And is that not covered by your current solar system? So there's a lot of factors that can come into play, but the best way to get those hard numbers so you can do that math is like to look at your specific site. And you can do that by getting those quotes. And those quotes they'll do for free. So you don't have to sign yet. You can look at that and see what those numbers look like before you make that financial decision. I know you had a question.
They usually give you a payback period estimate, don't they, in the quote?
They do, but it just depends.
Yeah.
And also, like, even if they have that payback period in the quote, you should do your own math too to make sure that that matches what you think you're going to be investing, because you're making the financial decision at the end of the day. You had a question in the back. I don't want to forget it.
The last line there is final cost to customer for savings. Can you give an idea what it would be after energy savings?
Yeah, well, so we looked at that example bill, right? And so that example bill we looked at was for a PGE customer. And so before they had solar and were creating enough electricity with their solar system, they were paying about $100 energy bill a month. And so with the solar, when their system is producing enough or they can pull from the credits that they've banked, you saw that their total was the fees, and those fees can range $12 to $18. So that's a pretty big monthly savings. But also, again, take that as a caveat because you want to look at your specific site. We just are sharing these examples so you have a ballpark, but your site is going to show you that truer picture. Yeah.
So I've been through these estimates before, and it seems a little discouraging, like, we have to take out a loan or something. And sometimes I wonder if I can just install one solar panel so that I can reduce my current electric bill by one panel. No?
Yeah.
Does anybody offer a program for that?
Yeah, so the question was, like, it can be discouraging to see that you might have to finance your system if you don't have the savings to like pay for a system outright. Is there like a smaller system? Like, can you just install one panel and just do some energy savings with that one panel? That's a great question. And you really can do most things because it's so customizable. So if you talk to your solar contractor that you're looking at and share what you're trying to do, like, hey, I don't maybe want to have an 8 kilowatt system that covers all my consumption. What would it look like if I covered a portion of it? And so they can put those projections in for you. Yes,
In line with that.
Yes.
If you wanted storage, what's the minimum number of panels that could give you the storage for an expected winter here?
yeah, that's gonna depend on your consumption. How much energy did you consume?
Well, during the year.
Yeah.
I have energy all the time, so I'm thinking of storage for times when I'm not consuming energy with enough to handle, say, 3 days worth of power outage.
And so the question was like, what would be the number of batteries and panels if you wanted to withstand like a 3-day power outage? And so I know this keeps being an answer for a lot of the questions, but it is going to depend on your consumption because you would want to match that to see what you can back up. For energy storage, folks that are looking to endure longer outages, just in general, are usually doing 2 to 3 batteries because their consumption is at a level that they would need that to be able to recharge and then keep the power on. And then also something to consider, if your panels are not producing and you drain all that battery, you need the sun again to recharge it. So if you're consuming a lot, even with those 3 batteries, and you use that whole bank, and there's no sunlight to recharge, then you wouldn't be able to recharge until you get that access to sunlight again.
I think, can I jump in here? Because
Yes.
we just did a webinar on backup heating, backup energy for power outages recently. And we did a lot of research on this. And I think one of the things that's really important to understand is that Nicole mentioned it, it depends a lot on what you're backing up. If you're just backing up your refrigerator and some lights, and maybe you have an induction stove and you want to be able to cook a little bit, that's one thing. If you want to heat your home, like run a heat pump off of one of these things, you would need a lot of batteries for that. So because the really big energy sucking devices in our homes are those ones I mentioned, the heating, the water heating. So turn off your water heater. When the power goes out, you can probably get by without hot water for a few days if you need to. It'll be warm in there. But turn off your water heater. Don't do laundry, because your dryer sucks a lot. And your stove, you have to be really careful if you have an induction stove or an electric stove. You have to be careful about using that because that's another big one. Don't cook a turkey. But little things like refrigerators and lights and things like that don't take a lot. So you could, with a relatively small battery, you could go for several days if you're really careful about what you're asking it to power.
And would say one panel charging 360 days a year provide enough battery storage to run 5 days a year minimum?
I would think so, yes. If that's all you're asking it to do, probably, yeah.
Sure, thanks.
So he's thinking of using it like a generator.
Yeah.
Is that what you're saying? Yeah.
Well, sort of.
Okay, I saw a lot of hands, so I'm gonna start at this end and then just work our way down, okay? Yes.
I have an estimate for a 5 kilowatt system. It was $35,000. So I went and did the research because I've been a contractor and a carpenter, and I'm like, it's $12,000 for materials, right? So then, like, if you put a bunch of bars up, collect, connective pieces, get an electrician in there, it still doesn't account for that other $23,000, and you can't do it yourself and get the rebates. And I
Yeah.
don't understand why that is.
Yeah, so the energy trust rebates, you'd have to work with a trade ally contractor,
Well,
but
if the point is to get solar on the roof,
yeah.
I can do it. Why do I need to pay another $20,000 that I can't afford, but
Yeah.
I wanna do the right thing?
Yeah, great question. So just, because I forgot to
I'm not
repeat
putting
it.
on blast,
No,
but
that's
just
fine, yeah.
Where I'm at with it.
Yeah, so I just want to repeat, just for folks that are joining at home. So, question was like, if the parts only cost $12,000, can I just do it myself? And why can't I get the incentives for doing it myself? So I believe you can still apply for the federal tax credit. That'd be something you just want to check with, you know, a tax professional to make sure before you go off and install. The Energy Trust incentives are through their program, and so they work with contractors who have reputations for installing long-lasting systems, who are pre-vetted, who can help with the interconnection piece as well. So if you're grid tied, you would be interconnecting to the utility, and the utility has certain requirements to make sure that system can be interconnected.
Totally get that,
Yeah.
but not $20,000 worth. You get a licensed electrician, you pull the permit, you get, the electrical company out there to connect it to the main, but I don't see where that
Yeah.
$23,000 is, even if you pay an electrician for the month.
Yeah, so
Yeah.
there's labor costs. So there's asking like, what is the rest of that cost? Well, there are labor costs associated with it. And so these contractors have costs to keep their businesses up and running so that they can install good systems and have good customer service and have the people that is required to do that efficiently. People are doing DIY systems. So if that's something you're interested in, definitely look into it. I would just advise, make sure you have the interconnection piece figured out so that you're not ended up with a stranded system. Because that's where things can get tricky just depending on those requirements. If you're off grid, it's a little bit different because you're not interconnecting to the utility. And so you can, yeah, well, and also to the utility, right? So like if you're, yeah, if you are, yeah, and so if like, for example, if you're in Portland, you're connected to the electrical grid, right? And so if you're gonna stay connected, and usually you do if you're in the city, there's, yeah, an agreement to connect because you're sending that energy back to the grid, and so you have to make sure that it's safe and that it meets the codes so that, they're not creating a liability with that. I know there's more questions that I saw down here. So I want to keep kind of working my way down. Did you guys? Yes. Yes. So the question was for panels, are there different grades of panels or some better than others? And so, yeah, there are different grades of panels, different modules, different manufacturers. For example, some people like to work with more locally produced product. And so these different solar contractors specialize with different modules. So if you're looking to get solar and storage, and maybe have researched a certain brand that you really like, ask them about it. It might be something they work with. You can get multiple quotes, and so that you can compare like, okay, this contractor likes to use these panels and this battery, different contractors might specialize in different battery brands. Like some might use Tesla and some might use Enphase. So it just depends on that. But it's good to do your own research and then, pair that up with what you're wanting when you have that conversation with the contractor. And I know there was more. Yes.
You have to get like the maximum size of a system for yourself to avail yourself of the incentives. Or, and then if not, do the incentives like kind of prorated or something to get a medium or a low, lesser size system?
Yeah, so the question was, do you need to get like a maximum sized system to access the incentives? Do they become prorated if your size of your system is different? And so in the example we looked at, solar for the like Energy Trust of Oregon standard incentive, that's just a flat incentive. But if we looked at like the storage incentive, it was based per kilowatt hour for that battery. So depending on your battery size, it would be that $475 per kilowatt hour. And so it just depends, but they do have a max on that, right? So it only went up to $5,700. So there isn't really like a prorated, but it's based on, some of them have like system sizes, like if you're getting more storage, you could possibly give more incentive. And then for the 30% dollar for dollar tax credit, you're gonna get a larger tax credit if you spend more, right? But that might not be the right path for your home and what you're looking to achieve with that. And then, thank you. I know you had a question too.
Yes, no, I look at that picture, I see those panels, there's not much going on, there's just light there. So you, can another source of light create that excitement?
Can something else behind, besides the sun, power your panels?
Cause I know when
Yeah.
it developed back in the old, the world,
Yeah.
we're finding that candlelight was exciting, about that certain material. We've got all over selling now, so.
Yeah.
If any other light source could,
Yeah.
anyway.
Yeah, so the way that our panels are working now and like how these solar contractors are designing and how we're getting like the best usage is for us to have that good, strong sunlight. And then that can, like your access to sunlight. So for example, if your panels are really dirty and you're getting less of that sunlight, that could decrease your production. So you want as much of that sweet sun energy as you can get. And that's going to be the best way to
Yeah,
power
so
your home.
you have like the more of the- which is steady.
Yeah.
There's a blackout. We're in Oregon.
How would you power that light if there's a
Well,
blackout?
it's almost like a central motor.
Yeah, yeah. So, you could maybe pair storage if you're thinking about from like a resilient side. Yeah. I know you had a question as well.
No, I was gonna say, the physics says you can't get more energy out of it, put into it. A candle will give you very little out.
But good idea. I like where the ideas are going. Yeah, so you had a question.
Tell me about end of life. So you get to the 20-25 years. What do you have to replace? The whole thing?
Yeah.
Waste? Well,
Yeah,
is
good
it
question.
cycle?
Yeah, good question. So the question was, what do you do at end of life? You know, end of 20, 25 years, what happens to your panels? And so the panel's lifespan, I'm going to just like rewind, is 20 to 25 years, but the inverters are more like 10 to 15, same with the batteries. So those will likely get replaced before your panels are up. And some folks who are looking to do that with their systems now might swap out their panels if the efficiency of the panels have changed a lot and it makes sense. And so, yes, you can update an existing system depending on what has phased out in its lifespan. And I think your second question was like, where does it go? Where does it get recycled? So we're coming up now to a lot of the older systems, folks who are early adopters, their systems are aging out. So they're getting to a place where they need to recycle their system. And so companies are now looking to fill that gap and help determine how that's going to be done. Since we're kind of stepping into that for the first time. Before that, sometimes panels could be reused for like education purposes. Sometimes panels are still producing a lot. They could be donated to nonprofits that help do installs for tiny houses, for homeless folks, or things like that. So there was a donation market, and right now there's a lot of people looking to figure out what's next for recycling. There are some companies that are already recycling, but thinking ahead, if we're all getting these panels, there's going to need to be more of those companies to help recycle.
We've got a great example of the city of Gresham where the forward murders are being replaced.
Yeah, we're, our carport solar array, we're at the lifespan of the solar inverters, so we're using a grant to replace those, and inverters are easy to recycle, right? It's all metal and great electronics inside of them. But with the solar panels, that's a little bit more challenging, and with the step, the IRA, with the last, the administration that's in office right now, there was a lot of, incentives for recycling companies to build and create that as part of the manufacturing funding, package, so that's where that recycling market is. Now there's demand for the material, the recycling companies will now build it. In the past, it just wasn't enough demand to make it pencil out. But very similar to flat screen TVs, right? Now we have, everybody has a flat screen TV. The market saw it, and now there's markets for recycling flat screen TVs because the glass and the electronics separated, so the same will happen with solar panels.
And let's do one last question, so we can wrap up and then, have everyone turn off and running.
I saw that you raised your hand.
So, you need to factor into your budget someone to clean them? Like
So
window washer?
maintenance is a great question. So the question was, do you need to factor in somebody to clean your solar panels? And so solar is low maintenance, not no maintenance. So if you get a lot of pollen and that is coating your panels, there are roofing companies sometimes, or sometimes installers know people who can help you clean those. Because if they're clean, they're going to be producing a lot more. Most folks who have solar panels, though, aren't having to do that very often. If you live somewhere in the mountains where you get snow and snow is covering the solar panels for a certain period, the sun is not going to go through that snow. So once that snow clears and melts off, then you'll be producing again. And sometimes the snow and rain help clean off your panel for you, which is also nice. Okay, so I'm gonna just jump into the end of this presentation and then we'll have time to connect with folks on more questions. So financing your system is pretty common. There are loans that are tailored to solar, and so some credit unions might specialize in solar loans. Sometimes your solar contractor will also have a third-party option to finance your system. It's really important, though, to realize this is a financial decision, and so you want to make sure you're looking at the fine print, making sure you're looking at the fees associated with financing your system. And if you have a relationship with like a local credit union or bank that you already work with, it's great to check with them first and see if they have some type of financing instead of working with maybe a bank you're unfamiliar with. And then we talked about the trade allies. So if you're looking to get the Energy Trust of Oregon incentives, you would work with a trade ally contractor. And so these contractors are vetted, they're more local, they work to install systems that last. And that's great if you have maintenance questions, because then you can, usually if you have maintenance or if you're looking to upgrade or update your system, a good first stop is checking with the company that you installed with. So you want to work with a reputable contractor that has a good reputation and will be around for a while. And then a good way to get connected with these trade ally contractors is the solar bid tool that's on Energy Trust of Oregon's website. It's just a quick form. You can put in what you're looking for, if it's solar and storage, and then they'll connect you with those trade ally contractors in your area. And it's good to always get 3 quotes if you can, so you can compare those. When looking at those, you'll want to look at the system size they give you, what they think their annual production will be, and also what fees they might have associated with the install. Brian brought up permitting, and so permitting can range depending on what county you're in. In Multnomah County, sometimes that's a little bit longer, but it can just depend. Permitting time has gone down since we're out of COVID, and so we've seen those times decrease. And then your contractor will help with those permitting, as well as applying for the Energy Trust of Oregon tax credits. So they'll help with that paperwork. The actual installation of your system would be only about 1 to 4 days. And if you're getting batteries with storage, it'll be closer to the 4 days. So the install is pretty quick, and then your contractor will also help guide you through the interconnection. And once you're interconnected, you'll be producing clean energy right at your home that you can use. And that's all I have. So, yes.
So one of our neighbors put in solar and paid the next door neighbor to cut their tree down as a part of that, which felt really kind of funny to me.
Yeah.
Is that common practice?
I haven't heard of that.
Put up solar?
Okay.
I mean, really, I thought it was amazing.
So good question. So we had a neighbor who got solar, and then they paid the neighbor next door to cut down their trees so they had more solar access. I haven't really heard of neighbors paying neighbors to do that. Some folks might make the decision to cut down a tree if it's shading their roof and it's where they get the most access. And then there's other options though, like trees also have other benefits. Having shade over your house is not a bad thing. So, if you are shaded on one roof, maybe do you have an outbuilding that you can install solar on could be an option, or can you look at ground mount? Also community solar. So if you still want to be part of community solar and see what bill reductions you can get by being part of renewable energy, that could be an option if you want to keep that big, beautiful tree. Any other questions? Yes.
So if you're on solar and battery and say generating more than you would need, you get paid utility?
Yeah, so if you're part of the net metering agreement, so like PG and Pacific Power customers, you would actually, you don't get paid, there's no check, sorry. But you get net metering credits. So if you send any electricity back out to the grid, that bi-directional meter is going to be measuring that and also looking at if you pull anything from the grid, and it creates that year-to-date bank of credits that you can pull from. So if you produced a bunch, you have a bunch of credits, and then the next month you don't produce that much, you can tap into those credits that you banked up.
If you had like solar and like really batteries.
Yeah, so if you're producing way more than you're using and just like exporting a bunch out onto the grid, that extra, if you don't use those credits, gets donated to low income subscribers. Yeah.
Those things, so you're accumulating points, and then you choose what to do with it, but it doesn't just immediately go back into crediting, your own power. And then if it's
So-
extra, then that gets divided up. If you're not using it at all, instead of keeping it for later, then it just gets.
So it will keep it for the whole net metering year. So it starts that April 1st and you can build that bank of credits. And so you can tap on that bank of credits for the whole year. It just before that net metering year restarts in April 1st. If anything you haven't used then is what
then
gets
it gets
donated.
divided.
Yeah.
It covers you completely.
Yeah, yes. And then so you have a whole year to use it. And so that's why that like conversation with how much you consume, looking at those energy bills, planning if you are going to be adding that EV charger is really important to think about and plan ahead so you can really match that consumption. Yeah. Yes.
So what if your natural disaster emergency happens pretty quick after you just donate back your credits? What happens?
Yeah, luckily it'll be April or May, so those are really good months in Oregon. And so if you had like battery storage, but it usually like I feel like it hits like January, February, and by April, like it's like those are the sweet months before it gets too hot. So
That happens, we pick it up with the utility company.
if you have storage, for example, and can keep recharging your battery, you have that. So you could be using that energy that you've stored in your battery.
Oh, I thought your storage also got wiped out.
So no, your storage,
excuse me.
yeah, so you would be refilling your battery storage with what your solar produces. And so it go to your house and also to the battery. And so like the example that we were talking about earlier, if you're like trying to heat your whole home and run the dryer and doing all things, you drain the battery and yeah, so you have to recharge it again. So that's where that piece solar plus storage really helps with energy resilience. Yes.
Do you know whether people do city gas and electric are ready for all these new stresses? Because I heard a story about California where everybody got on board and had solar and they were, giving extra energy back to the utility and the utility wasn't ready for it and it just didn't work.
Yeah, so there's a lot being looked at right now for the grid for like grid updates to think about like that electricity usage that we're going to be increasing. And so they're looking at that. The net metering credit really helps in our state to get credit for the energy you produce. But if you look at California, they rolled back their net metering. And so now they're on a net billing system. And so it's important for us to advocate and keep net metering here because that really helps us get that use of that electricity we're producing. So right now it's great. So we just need to keep it.
And the other thing is that utilities really like you to have solar and storage. They like that because it does have some grid benefits for there to be this distributed storage. So if, there's some individual advantages to having storage yourself. Part of it is for resilience. Part of it is you can take advantage of time of use rates to use that, charge your battery in the day, then use it from the sun and use it during the day and the evening, and then refill it again with cheap energy at night, that kind of thing. So there's some personal advantages to having storage, but the grid likes it because it's a way of reducing those impacts you were just talking about that the utilities don't like about distributed solar. So there's lots of benefits from the storage thing beyond just those that we enjoy ourselves.
Okay. Yes.
Yeah, absolutely.
Their state mandated energy.
Yep, for sure.
And then I think you had a question, and we have a question over there too.
So, in theory, Public Utility Commission has input on rate increases. Utility rate increases, electricity. You indicated earlier that it was a one-to-one relationship as far as the value of electricity that they buy back from you versus your purchase cost. What's the foreseeable future of that exchange rate?
Yeah, so the question was referring to the one-to-one net metering rate right now that we have, like for example, PGE, and what might that look like in the future? It could change. We saw it change in California. So if it's something that we care about and want to keep, we need to advocate to keep that one-to-one. And so if you are looking at solar and depending on when you're wanting to go solar, it's good to know what the rate is when you're looking to go solar. If you're not PG or Pacific Power, you can look at what that credit rate is for your specific utility because it can vary. But we definitely don't want it to go down. So it's important to pay attention to what's happening at the PUC, for example, and advocate for those things. Because as we've seen each year, the electricity energy rates have gone up. So it's really important to keep net metering and keep that strong. But I don't have a crystal ball.
Did you say the billing thing is in California? I assume they just charge you for the rate, but I don't think you can use the time of use with net metering because you're just you're not caring about the cost, getting it back, right?
And they have a lower rate, so they don't have like that one-to-one rate.
Essentially what happened in California is that in order to get the same kind of net metering benefits that we have here, you have to have a storage system.
Okay, that's.
And if you have a storage system, then you are gonna enjoy the same net metering thing. The conversation that has happened here in Oregon, there's nothing actually pending and that would change the status quo. But some of the utilities have been talking about an interest to change it and to move in that direction of California. Which, and if that happened, that would mean that it would really kind of push us all towards having storage if we have solar, in order to enjoy the benefits of net metering. And without that, you would have, there would be benefits, but they wouldn't be quite as lucrative, I would say, in terms of what's available now. So that's kind of the two things we know, the model that's out there here, which is 100% net metering, and in California where it requires storage to get that net metering benefit. And we don't know what's gonna happen here, but it's most likely gonna be one of those two things. And there's a lot of advocates here, as Nicole mentioned, who are really fighting to keep net metering as it is here. There's a strong advocate community who's fighting against it. Even any rumor of this gets, that advocacy group very excited and worked up. So you should feel confident there's people out there who are fighting to keep net metering, but we can't promise that it's going to stay the way it is.
Okay, so a couple questions, Pete, and then
I think we all gotta bring it back to what's important here. It's going the emissions, going electric, and, be cognizant of that. Because the cost benefit analysis of this is tremendous. Those who are parts. It'll be a better world.
I'm glad you brought that up because, you know, I think a lot of us can get really in the weeds on the nickels and dimes of some of this stuff, and it's hard to put a value on that carbon reduction piece. So thank you for bringing that up.
For these young people. And,
and then I believe you had a
Since
question.
I'm trying to budget this thing out, I am in. But the net metering at the end of the year, so you have $400 or $500 credit that's going to be donated. Is that then considered a tax deduction or something I can use on my taxes?
So the net metering credit is an amount of like kilowatt hours. It's not like $500 goes to an organization. It's, yeah, so it's gonna be that bank credit for energy. And so then anything you don't consume energy wise, that's what gets donated to the grid.
Don't you think it's fair to say, Nicole, that if you have a well-designed system that's been well thought out, that credit's gonna be pretty small, in most cases, because, unless you built a system that's too big.
My problem, I want a farm, so my power use go all over.
Gotcha.
So I can plan a system for January, February that's gonna be through the roof. Summertime, I'm down to almost zero, so. And the other question I had was the, heat pump water. Heater, can that be in a smaller, like enclosed closet type area?
It can be, you might, it does need airflow. So if it's in a small closet, you need to, either vent that closet somehow. You can vent them to the outside. You can put louvered doors on, that sort of thing. It can be, but it can't be, it needs access to air. So, yeah, I can help you with that if you have more specific questions, yeah.
On that water heater, is it a more efficient water heater that you could go from an 80 gallon to a 40? Or is it, you're gonna need a similar?
I think rule of thumb is, you know, if you've got a 80 gallon, if you got a 80 gallon water heater right now, unless you're, if it's oversized for what you need right now, then you could probably shrink. But in general, you're gonna need about roughly the same as what you have. Some people no, it doesn't make hot water faster. In fact, some people advocate that you should upsize. I don't personally believe that. Some plumbers will tell you that. We went from a 50 gallon gas to a 50 gallon heat pump water heater. We've never had problems. But some people will tell you should upsize when you go to a heat pump water heater. You know, it really depends a lot on how much hot water you use. But in our experience, 1-to-1 is the way to think about it.
let's do a round of applause for the